I've just made a 1200 euros mistake. This is a 16-inch MacBook Pro M1 Max that I have butchered in an attempt to fix it. A very difficult to investigate partial short, the worst nightmare for any technician. Let's find out if I can fix the board and also the damage that I've caused. Yeah, it looks very nice. It's dead. If we try to power it on, well, to plug it in, we can notice the instruments. If I put them on the screen, you can see the USB supply right there. So let's try one port. 5 volts, 7 milliamps, sorry. 5 volts, 7 milliamps. On the other side, we have another port here. 5 volts, 7 milliamps. I don't have the MagSafe, so I can't test that one for the moment, but yeah, that's a problem. So if we flip this back, we need to remove the battery data line. Yeah, so that is removed, and because the battery is original, we know that the power has been cut off the board. And now we're gonna start investigating the board a little bit. So this is a bit more complicated than the older models, but there's no problem with that. We have a PP bus always on, which is on these fuses here, and if we measure them, yeah, we have a fairly lowish value. I'm not sure if this is correct or not, but it's low. But it's low, but it's not that low, because I can't inject in a line that is 0.1, because at 0.8 volt it will probably take a few milliamps, like 6, 7, 8. Yeah, so I can't see anything right off the bat. I'm gonna measure some inductors, just like this, arbitrary. Yeah, these all seem fine. I'm gonna measure the inductors here on the NANDs. Yeah, they all look fine. I'm gonna measure some coils. This seems okay. This seems okay. This is okay. Have another coil here. This is fine. And I think that's it with the measurements. Yeah, this is the same PP bus always on. I can't see here anything out of the ordinary, so unfortunately we'll have to take the board out and see what's on the other side. I think there's a short circuit by the way the power acts when I plug in the USBs, right? So that's probably it, but I'm gonna have to remove the board and have a look on the other side. Maybe there's some liquid damage, although you can't really see nothing much. So it's gonna take a lot of time to remove this, because there's 10,000 screws and connectors. I'm gonna be right back when the board is removed. Also, I am a bit worried now, because I have removed the board, and I had a brief look, like visual inspection, and I can't see nothing weird with it. So let's look under the microscope, but with my bare eyes I couldn't see anything. Okay, so the PP, well, the bus always on, we tested. There's another 3V8 always on line that is important. It's right here. Yeah, but it's pitchy. So I really don't know where to go from here. I think I'm gonna take a USB connector and I'm gonna connect it to the board and see where the power goes. One sec. Okay, so let's connect the USB, and we're getting those 5 volt 6 milliamps. Let me put in DC voltage the meter, right? And let's go first and check the PP bus always online. What is this? 008. That's definitely wrong. 08. 08. How can that be? And the 3V8 always on? Nada. Good. I'm gonna have a cigarette and be right back. Okay, so because our PP bus always on is that bad, let's have a look where it's being produced. Okay, let's put the meter back in diode mode. Okay, and let's do some measurements around it and see if we have something out of the ordinary. Okay, so this is a bit low. In theory that should be 0.4, something like that. Okay, let's remove that. Let's remove the chip and see where we're at. This was crazy. I had to go like 480 with the hot air. Amazing. Okay. Let me tweak that. I really hope it's this chip the problem. Yeah. So the board is still hot, but I'm gonna measure this one. It's still low. This one is still low. No, right. So this is low, and it says it should be 0.48, and that is interesting. We have a this is also low. and this one is also low. Right, let's have a look again. So we are looking at this. Oh no, this is good. And this is low. And this is low. And that is bad. Yeah, so it's this line here on these large cups. This is really low, but it's not this low. That I can't inject voltage. So if we inject voltage there, right on these caps here, let's see 0.8. 0.8 volt. If I inject here 0.8, I get 8 milliamps. So I won't be able to see those 8 milliamps because the only problem that we could have is a partially shorted cap or a shorted MOSFET. So what could it be? These ones? No. So here we remove that chip. We have here, what is that? Those are the current sense resistors, right? And they go here on the other side. Yeah, we have a MOSFET here. So we can have a shorted MOSFET, partially shorted. Yeah, on this one there's nothing. Okay, then on the other side of the board, so here okay, let me rotate. I need to rotate and then I need to mirror it. I don't know why. Yeah, we have this one. Is this a double MOSFET? Or what chip is it? I don't know what chip is it, this one. Yeah, it's a MOSFET. Okay, let's remove this one. Charger phase 2. Yeah. Let's remove this MOSFET and see where we're at. This is gonna be a pain to remove that one from there. We also have those large caps there. Pin number 1 is here. Okay, let's go back. here to our chip. Well, this is 0 now. How is this possible? What happened? Did we short any of the caps? Zero. What? Well, that's good because we can inject voltage now. If it's 0, definitely sure there is no short on this side. So these 4 are okay because they all 4 pins go here and these are separated. Here we have, how is it down here? Now here we have the first 3, then this is alone. I think I broke that track. Did I damage something? So that pin should be alone, this one here. In case anyone wonders, we're gonna fix that. And the other 3 should go to the fuses here. Do we have a short on the fuses too? Oh boy. No. So the fuses are fine. These pads are okay. This one is open, but it will come here. And these 2 are ground. Yeah, those are ground. Good. So let's get back to the other side and see what went wrong. Well, let me tell you that probably one of these large caps was partially shorted. Ah no, so the short is gone, but we still have the low reading. We still have the freaking low reading, 0.8. So it means that neither that one or the MOSFET was to blame. That is crazy. Okay, let's look back. Wave was always on. Let me find a donor board. So this is sort of a similar one. It's an 82442. It's the same computer, but a 14-inch. So let me figure out where the always on is here. But this is extremely damaged. Let me find another one. So this should be a better one. As an example, let's see how our always on line is here. 0.7 watt. I'm measuring, sorry. Caps. 0.4. Yeah, so we have 0.4. Oh, you can't see. You can't see nothing. So on this donor board, yeah, we have 0.4 on the always on line. 0.4. And this one is 0.0 something, and I really don't understand where that comes from. This is a problem. PP bus always on. So if I inject in this one, if we inject, where is it? Here. Always on. Yeah, 0.09, 0.1. That in ohms is low. But if I inject 0.8 volts, so you see there we have the, it takes 8 milliamps. 8 milliamps. Okay, I'm gonna go higher with the voltage. If we go like 5 volt. Yeah, so this should be a 13 volt line. Now let's go with 5. So if I go with 5, I get 65 milliamps. 65 milliamps. Let me solder a wire here. Maybe 65 milliamps we will be able to see somehow on the thermal camera, because all we did so far was just ruin stuff. I've ruined that MOSFET. I've ruined the charging IC. Okay. Okay. Let me find the ground somewhere. Maybe like that. Let me take the thermal camera. Let's see first without. Without the, how is it called? The macro lens. And I need another cable. 1 second. Yeah, we have 65 milliamps. Let's go to the window screen. Let me also find the window screen. Reconnect the camera. Okay, and see what. Let's see if we can see some heat marks. Is there something here? Let me turn off the supply. Yeah, it's here on the other side. So it's the audio amplifiers, and I ruined the charging circuit. Okay, let's see here. Oh la la. It's the amplifier in the middle. That's great. Okay, let me turn off the top camera. Amplifier in the middle, Jesus Christ, and I ruined a perfectly good board. Yeah, pins are the same orientation. Good. Some wick. And to be honest, my first thought when I was looking at the board and I saw no issues was actually an audio amplifier. Yeah, so I think it's good. Now let's see what we have on the always on line. Let me remove this. Let's do a bit of cosmetics here. We're gonna have to fix that crap. No, it's never the MOSFET. Never. Make a note of that. Alright. Let's see now what we have on always on. Four, five. Different story. Okay, so I'm gonna stop now and I'm gonna prepare some donor parts from donor boards, and we resume when I install them back. Okay, so let's fix what we have broken. Well, not really. I'm gonna start with the audio IC. Let's see what the orientation should be for this one. I can't read anything of it. So let's try to clean it a bit. Yeah. I can't see nothing. Yes, I saw a point. Yeah, trust me, it's the same chip. Yeah, so here we can see some marking. SN91 0101277 yeah, and that's okay. So we will put it right here. Okay, and let's try to solder it. Good. We're good. Now let's move to the interseal chip, which is right here. First we need here a resistor. That's a 0 or 1 ohm, something like that, very small value. Good. Let me grab it somehow, maybe like this. It's not from the exact donor board, it's from a 14-inch M1 Pro. But yeah, it should be relatively the same. So we have those big coils here, that's why this takes a lot of heat. I'm gonna raise it a bit like this, because I need to put back the interseal chip. Well, I have the interseal version from that MacBook, but it's marked differently, so I'm gonna use the one that I've chirped. Hopefully this is still okay. Let's see if we can solder it with this air and speed temp. If not, I'm gonna increase it a bit. We have the big two coils, switching coils on the other side, and that's why it was very difficult to remove this one. But I already heat stressed it last time. And it's not melting. And one more time. Yeah, I think now it's back into place good. This is a bit stressful. And now let's see what we have damaged here. So we have to fix that trace. Let's see, is this too big of a wire? Yes, definitely too big. So we're gonna use this. Maybe in half. Like this. Oh boy, the board is so hot. Yeah. Good. Okay. I need some solder. Right over here. Good, that's perfect. Okay, let me clean. Okay, let's get the green stuff. Good, and let's fix this. I'm using the UV light. Excellent. So let's cure this a bit further. Perfect. Okay. On the upper side it's fine. We don't care about that. I have a brand new chip here, MOSFET. So let me add some solder on it. That's too much. I need to get some off. See if I can make this. think that's fine. Okay, so let's see how this goes here. It was supposed to be like this, right? I made a mark somewhere, didn't I? Yeah, the scratch is right here. And this is gonna be the struggle of the evening. Let me put something back here. And this should be like this. Okay. Okay, let's see. I think it's properly aligned. Good. Is this still coming down? Yeah, it is. So it's not ruined. Okay, I think this is the best I can do with cleaning here. Let's do some cleaning over here. And let's do some cleaning over here. Okay, that's good. So now let's connect the USB supply. I'm connecting it in 3, 2, 1. Yeah, and we see something different. It's trying something. Now let's see. Yay, it went to 20 volts, so we're fine. Let's see what we have now on always on. Yeah, we have 12 volt. Good. So I think the laptop is fine. I was a bit stressed about this one. Yeah, so let me put it back and we're gonna have a look when it's all back together. Okay, so here we are with the final test, right? I've got all flexes back together. I still have to put those shields, but that's just cosmetics. Let's see what happens now. If I plug in the power, I'm gonna use one of the USB-Cs and we can look up there and see what's going on. Yeah, we got 20 volts and a battery charging sign. So we wait for a couple of minutes to have this charged, and yeah, I'm gonna be right back. Okay, so let's see the moment of truth. Power on. Hey, we have an Apple logo. It is loading. Let me put it like this. Okay, so I don't think we can really see what's written there, but we have picture, so this is good. I'm going to turn it off. Yeah, and this is it. It is still charging. This was the repair. I made a mistake. It wasn't quite dodgy, but mistakes happen. The important thing is that we can fix them, and we have eventually saved a 1000 euro MacBook Pro that will still be used in the future. Also the data is saved. So this was this repair. Thank you very much for watching me. See you next time. Give me a like, subscribe if you didn't already, and bye for now.